Good afternoon and welcome to our webinar on our Instrumentation, Measurement and Control Graduate Apprenticeship Programme. I'm now going to hand over to Alan Faulkner-Jones, one of our Engineering Programme Directors. Alan, over to you.
Thank you very much, David. Yes, so the aim of this webinar is to give you an overview of our Bachelor of Engineering with Honours Graduate Apprenticeship degree in Engineering, Instrumentation, Measurement and Control. So the programme itself sits alongside two others which share some common components. So they are the Bachelor of Engineering Honours degrees, Engineering Design and Manufacture, Mechanical and Electronic Variations. So the programme itself is delivered 1 day a week on campus, and 4 days a week we recommend is given by the employer for additional study. The Instrumentation, Measurement and Control is a 2+2 graduate apprenticeship degree, unlike the other programmes that we offer. So years 1 and 2, when I say campus, I mean Forth Valley College in Falkirk, and years 3 and 4 are Heriot-Watt University in Edinburgh. There are 3 semesters in a year for a graduate apprenticeship degree, unlike a traditional undergraduate degree, which only has 2. So this covers about 42 weeks of the year, and there's still the traditional breaks at Christmas and Easter, and there is still a break over summer, although it's not the entire summer, of course. Major advantage of this, as opposed to other routes, is that it's still a 4-year programme, which still arrives at the same point as a Bachelor of Engineering with Honours, like an undergraduate degree, in the same amount of time, unlike other routes, as I say, such as part-time, which could take up to 8 years. So how does it work? How do we manage to squeeze it in? The answer is that we don't. It's not 2 things on top of each other. It's not a full-time degree on top of a full-time job. What we do is we have a rather large overlap in the way that we assess the programme. So there's about 20% of the programme is what we would recognise as traditional university learning, and 80% of it is more practical, work-based approaches. So these are practical or theoretical exercises with evidence, which the content for which is agreed by the employer. Usually these are tasks that the apprentice would be carrying out as a matter of course as part of their normal job, and what we do is that we can assess the evidence they submit to the university against the learning outcomes for the courses and the programme that year. For the university learning, that's assessed on campus, so it can include exams, coursework, class tests, that kind of thing. But there are far fewer exams in graduate apprenticeship programmes as compared to traditional degrees as well. The university learning are usually delivered in the traditional part of the academic calendar, so semesters 1 and 2, which enable reassessment to take place in semester 3 as required. For all of these courses, there'll be tutorial exercises provided to help guide learning through the courses, which those particular examples are not assessed, so you get 4 solutions to help you work through it. And as I said, there might be exams or in-class tests, but the work-based learning courses, like I said, is evidence-based. So the evidence can be submitted at set points throughout the year. There's not fixed deadlines for a lot of the work, because we can't dictate the particular activities that apprentices will take in their specific jobs. So we like to be as flexible as possible. So each course has its own course specification document, which lists learning outcomes which has to be met, and specific activities, exemplar activities, which can be used to base work-based activities from. Feedback on the evidence will be provided, and there's an option to resubmit in certain circumstances. And there are no exams in the work-based learning courses. So to act as a focus for discussions between the apprentice, a personal tutor at the university, and their work-based mentor in the workplace, we have a quarterly review system in place, which doesn't have to be exactly 4 times a year. It can be more than that, but it has to be a minimum of 4 times a year, which helps the apprentice and everyone else to keep up to date with the requirements. So what we have as part of this is, as it says there, the ILA, which is the Individual Learning Agreement, which is agreed between all three parties, which helps the apprentices, their employers and the university keep track of what's being learned, what's being experienced, what's being gained, what potential gaps there are that needs to be filled in plenty of time to sort them out, and then how the portfolio is progressing. The discussion at the quarterly meetings between the three parties, and to demonstrate how the GA frameworks are being discussed. This is largely when the course specification documents come in as a point of discussion for what activities are coming up, what activities have already happened, and so where the evidence is coming, and in certain circumstances what activities the university might need to provide simulated activities for. And then, of course, as a plan, there's always specific goals set for the next meeting and then reviewed the previous one. So support, obviously this is a three-part system with the apprentice, the university and the workplace. So obviously there's going to be lots of supports provided by both the university and the workplace in the shape of the mentors. So the university is providing obviously lectures, tutorials, seminars, that kind of classroom type activities with practical examples. It helps the apprentices identify supporting resources, providing individual feedback, mentorship in certain situations, guiding this apprentice through this 4-year degree program, possibly towards chartered engineering or incorporated engineering status, supporting each apprentice with their individual learning. Each apprentice will, although they're taking the same program, they will come out of it with different set of experiences based on their individual company and job role. So the mentors providing the underpinning support that is obviously required for the apprentice in the workplace, managing and supporting the progress of the GA on a more regular basis than the quarterly meetings, providing support in certain situations for the transition from school to work, or indeed from one area of work to another, and the progression through from their initial role to at the end of the degree program, their role as a fully qualified engineer. Line managers can act as a coach to provide a short-term support, but we really suggest that the mentor is a secondary, an extra person to provide that extra support necessary. The mentor can also suggest the work-based problems that are required to the evidence to be gathered for the apprentice to fulfil their portfolio outcomes, and set the regular meetings in collaboration with the personal tutor to observe the progress. And obviously they need to be able to be open to discuss any concerns that the tutor or the apprentice may have. So on the benefits of industry, so obviously there's several benefits to the industry for this new graduate apprenticeship scheme. A learning organisation at the university where we can allow the apprentices to experience knowledge and understand, to experience situations where they can build their knowledge and understanding of the specific areas of engineering, instrumentation, measurement and control. It brings a new skill set to the apprentice, and each individual apprentice will enrich their cohort because they're coming from different places, working for different companies, so they all have a different way of thinking about it, and we find is that they can really help each other to understand what's going on. It's an improved quality of service. Each individual is recognised as being an individual, so they all receive their individualised and tailored feedback and guidance. Obviously helps the company to retain their apprentices up until to the introduction of the graduate apprenticeship scheme. Once apprentices had reached the end of their modern apprenticeship, there really wasn't any more places to go except to leave the company and pursue a degree full time. So this offers a continuation of the apprenticeship family, and obviously it's helping the existing employees to enhance their skills. So why Heriot-Watt? Well, Heriot-Watt has a strong heritage in engineering-related education. It was the world's first mechanic institute, founded in 1821 to provide technical education to the working classes. We're recognised for high-quality engineering programmes. So we're ranked number 1 in Scotland for the National Student Survey last year, and number 2 in Scotland for the Sunday Times Good Education Guide. These are for chemical and process engineering programmes. In terms of accreditation, the program's only been running for a year so far, so we're going to apply for accreditation in 2023 when the first cohort will be set to graduate, and the accreditation will be sought from the Institute of Instrumentation, Measurement and Control. Program is designed to fully meet the academic requirements for registration at an incorporated engineering level and partially meeting the academic requirement for chartered engineering with a small amount of top-up in the extra work experience or top-up master's degree, for example. So the programme aims to produce Bachelor of Engineering honours graduates who have a sound basis in the theoretical engineering principle and methods, as well as their application in the context of design and analysis, are able to operate in teams as well as in multidisciplinary contexts, have problem-solving skills and the ability to apply such skills by developing the innovative solutions to society's practical needs. They need to have an appreciation of the wider societal and commercial influences on and the impact of engineering, and have developed personal qualities and professional competencies of practical engineers. And obviously these will be tailored and contextualised to the needs of their job role and their individual company. And obviously at the end of it, they'll gain the very specific IM's instrumentation, measurement and control practical skills. In terms of the programme structure itself, as I mentioned, the first 2 years are at Forth Valley College in Falkirk, but it maintains this structure. So there's 3 semesters, as I mentioned at the beginning. So the core courses are constrained to a specific semester. So for the first few years, these are the maths. So we have Maths for Engineers and Scientists 1 and 2, each in semester 1 and 2 themselves. And then we have these courses which span across the entire year on the specific subjects of working in engineering environment, measuring instruments, fundamentals, piping fundamentals, analog electrical fundamentals, digital logic. And then they have an option to choose between chemical engineering fundamentals or mechanics fundamentals. Into year 2. So there is an option for advanced entry into year 2 based on certain more advanced qualifications, such as an HND. Obviously, when you're applying for the programme, if you just mention it in your initial conversation, and we'll look at applications for advanced entry. Maths continues into year 2 in the face of Maths 3, which is the highest level of a maths-specific course that is required. That sets you up for the entire 4 years of the degree. The rest of the time will be work-based learning support. And then the all-year courses, so in control systems, supervisory control systems, sensors, signal transmission, fluid mechanics A, digital design and programming. And then in year 2, there's optional courses which you select one of these, so either working in a hazardous environment, thermodynamics A, or pneumatics and hydraulics. Year 3 sees the apprentices come back to Heriot-Watt University, where we get certain of these courses shared between other graduate apprenticeship courses, so they get to be a part of the wider cohort of the other, not only the other engineering degrees, but graduate apprenticeship programs across the entire sector. So courses such as project management are shared between quite a few different programs, and engineering management obviously shared between the engineering programs. So there's also equipment for chemical and energy processing, process modeling, design of control systems, safety, PLCs, programmable logic controllers, and as I said, engineering management. And there's another option between electrical machines, fluid mechanics B, and thermodynamics B. Obviously, for the B courses, you have to have taken the prerequisite A courses in order to continue on that pathway. Finally, in year 4, the honours year, there's some standard courses in advanced subjects. in fluid transportation and storage, advanced safety, advanced control, and batch processing and sequential control. And then the remainder of the year is spent on the design project and your research project, which is the honours dissertations and big projects, which will be guided by both academic in charge of the courses as well as the requirements of the business. Hopefully that's given you answers to all the questions and a top-down overview of the contents of that Instrumentation, Measurement and Control Graduate Apprenticeship Programme. Thank you for listening.
Thank you, Alan. Thanks for that great overview of the IMC programme. So really, any further questions, please just email us at ga@hw.ac.uk. And you can also find out information on our range of other graduate apprenticeship programme on our website, which is hw.ac.uk/GA. Thank you very much for attending the webinar today, and we hope to see you soon at a follow-up session. Thank you.